Welcome to Summarize Science. Imagine an AI playing Minecraft that builds an amazing castle, walks away to explore, and when it comes back, the castle looks completely different or is gone entirely. This memory problem is a huge challenge for AIs that generate interactive worlds, and today we're looking at a fascinating solution called memory forcing. Current AI models face a major trade-off, as you can see in these diagrams. Some models are great at exploring and creating new scenes, but have terrible long-term memory, leading to inconsistencies when they return to a location. Other models have great long-term memory, but struggle to generate new areas, getting stuck in a creative rut. The goal is to get the best of both worlds, creativity in new places and consistency in old ones. The researcher's solution is a framework that forces the AI to use its memory more effectively. It combines short-term, temporal memory, which is what's happened in the last few seconds, with long-term, spatial memory. And that long-term memory isn't just a collection of old pictures, it's an actual 3D point cloud, like a digital blueprint of the world. To teach the AI the skill, they use a clever hybrid training method. They train it on two different kinds of gameplay data, one focused on exploring brand new areas and another focused on revisiting the same locations over and over. This teaches the model when to rely on its short-term creativity versus its long-term 3D map. They also use a technique called chained forward training, which forces the AI to make long-term predictions and learn from its own compounding errors. The core of this long-term memory is called incremental 3D reconstruction. As the AI moves, it selectively captures keyframes to build and update its 3D map of the environment. It doesn't save every single frame, only the ones that add new geometric information, making it incredibly efficient. When it revisits an area, it checks its current view against the 3D map to instantly pull up the relevant memories. So, how well does it work? The visual results are night and day compared to other models. Here you can see memory forcing maintaining a perfectly consistent scene when returning to an old location, while other models generate distorted or completely different structures. The world it generates feels stable and persistent, just like in a real game. It's also great at generalizing to completely new types of terrain it wasn't specifically trained on. While other models' quality degrades or they create bizarre landscapes, this method generates stable and coherent new worlds. Beyond just looking better, the system is remarkably efficient. Compared to a previous memory-based model, their 3D map approach uses over 98% less storage and retrieves memories over 7 times faster on average. So to recap, the memory forcing framework solves a key problem by teaching an AI to intelligently switch between short-term and long-term memory. It does this through a specialized training process and an efficient, 3D map-based memory system. This is a significant step towards creating truly persistent and believable AI-generated worlds. This technology could revolutionize gaming by enabling endlessly creative and consistent environments, and it has huge implications for training robots in realistic simulations and building the metaverses of the future.